Alright, so we're going to start our new unit today. I know there was a couple of problems we didn't get to last week on topic 1, but we will go over those at some point this week. But I just want to make sure we get through how to solve how to solve an exponential and logarithmic equation. Alright, so if we look at these first couple of examples, these we can actually solve with the chart as long as we rewrite it in the other form. So if we look at A, converting it to exponential form, right now it's a log form because it says log. For exponential form, we would write 36 as the base, 2, 3 halves as the exponent, and the argument is what the exponential is equal to. So this is actually a really good review right now. We will see these on the final, so you have to recall what these exponents mean. So a rational exponent of 3 halves means you take the denominator root, so the square root of the base, 36, and you raise it to the numerator power, which is 3. So from here, the square root of 36 is 6, and looking at the chart, 6 cubed is 216. So the answer to this equation is just 216. But again, this is a nice review of how to convert it to logarithmic or exponential form. Alright, this one is actually not solving but evaluating the log. But again, we have to figure out the exponential form. So here we would do 16 to what exponent is 1024. And this is kind of why I wanted to do this before the quiz, before you turn in your homework. This you should be able to do without a calculator. The quiz that we take this week, which I'll make on Wednesday, I won't make it tomorrow, but your homework's still due tomorrow, is to find a common base between these two. Now, it might be true that 16 to some exponent is this number, but our charts don't go to 16. So the easier way is to actually find a common base. So what row, looking at the chart, do both of these numbers belong to? 16 and 1024? Well, the one that I can see is that they both belong to base 4. Now, because they both belong to base 4, they probably both belong to base 2. But I can't see this number in the 2 row. So I'm going to write them both with the base of 4. So 16 is 4 squared. And since 16 has the x, this one has the x, equals, here, 4 to the 5th power gives us the 1024. So once you have the same base, then you can cancel out the bases and set the exponents equal. 2x equals 5. And solving for x, we get that it's 5 halves. So again, you will have some problems like this where it's not just a positive or a negative or a unit fraction, but it's a combination of them. So you need to be able to find this common base and then solve for the needed exponent. Alright, and then this one, again, still a logarithmic equation, but this time we're looking for the base. So what to the 3 halves exponent is 27. So again, not on the quiz this week, nothing like this will be on there, but it is a good review because rational exponents, like I said, are going to be at the end of the semester on the final exam. So here, to get rid of x, we raise both sides to the reciprocal exponent. So we're going to raise both sides to the 2/3, and then here we get 6 over 6, which is just 1, and anything to the 1 is itself. Over here we have to do what we did on part A and convert this to a radical equation, or a radical expression, and then we can figure out the value. So we take the cube root of 27 and we square that. So the cube root of 27 is 3, and then 3 squared is 9. So the base here that we would need in order to get this value is 9. Alright, So what I want to do is check these answers in the calculator, because the ones that we do today, they're not going to be on our chart, so we're not going to be able to solve them by hand, but I need to make sure you can type these in the calculator. Alright, so for the first one, we're going to do log base 36 of 216, because that's what we got for x, and we should get 1.5 as the answer. So we do alpha window 5, this log base function, and that gives us a little subscript. So in the little subscript we want to do 36, and in the argument is the 216, because that's the answer that we got. So log base 36 of 216 is the 1.5 that we were given. Alright, so checking B, alpha window 5, we put the subscript as 16, and we put the value as 1024, and we should get 5 halves as the x, because that's what we solved for. So math, enter, gives us that it's 5 halves. Alright, and checking the last one, we solved that the base was 9. So the other way you can do it is math, alpha math, alpha math, but I like alpha window 5. I think it's easier. So here we're going to put 9 and 27 to get the 1.5 that we were given. Alright, so again, to get the log base, in case you were absent or didn't get it last time, you do alpha window 5, or math, alpha math also gives it to you. Alright, because we are going to need this today as we're solving these logarithmic equations. Alright, so the next, I consider that case 0, because this is just converting forms. We're not actually solving it. This is case 1 right here. So case 1 is when you have logs on both sides. So right here, logarithmic equations are equations that involve variables as the argument of the logarithm. So actually, in the first couple of examples, the only one that had x as an argument was a. So this one is the only one we would consider an logarithmic equation. This one is just evaluating it, and this one's finding the base, which is more of a rational exponent problem. Alright, so the x's need to be within the argument. So right here, if x and y are positive numbers, because we saw last time we cannot have negative numbers inside the log, and the bases are the same, then you can just cancel out the bases and set the arguments equal. So if and only if x is equal to y. But again, two things have to be true. The bases have to be the same for you to cancel them out, and there can only be a single log. Once we start adding logs, that requires another operation that we have to do. But right here, log base 2 is the same, so we can just cancel out the bases, and we have that x equals the 7. The two arguments are equal to each other. So that's what we're going to do here. But again, they have to be positives. So we are going to run into some extraneous solution cases when we get an answer, but then when we plug that answer back in for x, we get negatives, and then it's no solution. So then that answer doesn't work. So we do have to check our work to make sure that we get positive arguments. Not x's, but when we plug it back in, that number needs to be positive. Alright, so I consider this case 1. When we have two logarithms with the same base equal to each other. So right here, log base 7 of this argument equals log base 7 of that argument. So we can cancel out the bases, and we can set the arguments equal to each other and solve for x. So here, just subtract x to get 5x. And then on the other side, add the 16 to the -1 to get 15. dividing it by 5, we get x is 3. Now, as long as we plug them back in and we get a positive number, we're good. But if we plug them back in and we don't get a positive, then that answer is extraneous, and we don't have a solution. Alright, so plugging 3 back in, we get 3 times 6. 6 times 3 is 18. 18 minus 16 is 2. So log base 7 of 2. If this side is 2, then we're good. So over here, 3 minus 1, 2. Log base 7 of 2. So they're equal, same number, both positives, so we're good. So this is actually the answer to that one. But you do have to check to make sure that they're positives. Alright, so part B, bases are the same, cancel them out. Set the arguments equal. 2x minus 7 equals 3x minus 9. Solve for x. So that's x there. And add 9. And we get 2. So here we get x is 2. But then we plug them back in. So here, log base 5. 2 times 2 is 4. And 4 minus 7 is negative. So negative 3. But this side, I mean, we're going to get negative 3 as well. But because it's a negative, I mean, we really don't care about this side. This cannot happen. This is an error if you try to type it in the calculator. So the answer that we got, so this is an error. It's not in the domain. So because that's negative, we would say that this is not a solution. So this logarithmic equation has no solution. So you do have to be very careful with logs because they're restricted domains. They have to be positive numbers, no zeros, no negatives. If you end up with 0 negative, then you ignore it and you throw out the solution and it's no solution. Alright, so that's when you have the double logs, just 1 on each side. Again, if you have 2 on a side, that's a separate case, which we're not doing until after we do properties. So here we are in case 2. So case 2, and I consider the exponential and the log the same case because they follow the same steps. So you can solve a single exponential or logarithmic equation. That means there's one exponential or one logarithmic expression by using the definition to convert the forms. So remember from last week, or we did at the top, we're going to use the definition b to the x equals y to convert it to log base b of y is x. So this is what I mean by converting by definition. We're just going to get it to the other form. Alright, so we go back to good old SABMEG. We're undoing the order of operations. The important part is that you isolate that single exponential or logarithmic part. So here for this problem, the base of the exponential, so I know it's exponential because it doesn't have log. The base of the exponential is e, separate it from the 6, and the exponent is 0.25x. That's the part I'm trying to get by itself. I'm trying to isolate the base and the exponent. So the first thing I do is subtract or add the k value. So here, I'm going to subtract 8 from both sides. When I subtract 8, 6 e to the 0.25x is 12. But again, the base is still not by itself. So I still need to get this part by itself. So I need to get rid of the 6 in front. So I either divide or multiply. In this case, it's a value, so I divide it by 6. So e to the 0.25x equals 2. Now, the exponent step for GEMDOS, this is when you go from exponential to log form. Or in the case over here, if I give you the log, you go back to exponential form. So we want to take this and we want to write it as a log. So this is me converting the forms. So we're going to take log. E is going to be my base, so that's the number that's going to be here. The number that I'm taking the log of is what it's equal to. And the logarithm is always equal to the exponent. So this number is going to come to this side. The parts that I would do if you get confused, you know that the base drops. That becomes the base here. The exponent has to go to the other side. So if the exponent goes to the other side, there's only one place left for the 2 to go, and that's inside the log to be the argument. Alright, now, this part we're going to talk a little bit more about. But for now, since we know how to do log base and we know how to get the e, we're just going to do the log base with the e there. So alpha window 5. We're going to put second divide as the base, and we're going to do 2 here. So I'm not going to write that number down. I'm going to leave that here in my calculator. That is this number. I'm just going to take that number and solve for x by dividing that number by 0.25. I mean, 0.25 is 1/4, so you could just multiply it by 4. But we're going to do what it says. So x is divided by 0.25. And I can round that. Let's do 3 decimal places since it doesn't tell us. 2.7725 is going to round to 3. So that's the value of this one. A lot of these exponential equations are going to end up being decimals because they're not perfect logs. They're not logs that are on our chart. Alright, logarithms work the same way. So over here, we have to isolate the log by adding or subtracting first and then multiplying or dividing. Then we convert forms, and then we solve what was in the grouping symbols, what's in the parentheses. But first, I got to figure out what's the log part. So it's always the log, obviously. And then what's inside the parentheses is 8x. This is the part we're trying to isolate. So I add or subtract the 7, so minus the 7 from the 2. And I get negative log base 3 of 8x is negative 5. So then here, again, the log is still not isolated because I have that negative in front. So I'm going to multiply or divide, it doesn't matter, by negative 1. There's like a 1 there, by negative 1. And we get log base 3 of 8x is 5. Now, once you're here, now we're in log form, we need to convert it to exponential form. So we want the base of the exponent to be the base of the log, so this is going to come down and be the base. What the logarithm is equal to becomes the exponent, and the argument is what the exponential is equal to. Now this number we could actually get from the chart. So if you go to the chart and you do 3 to the 5th, you'll get that it's 243. But we're going to need that number over here anyway to divide. So we're going to do 3 to the 5th is the 243. And then I just take 243 and divide it by 8. Divide it by 8. And again, I believe it's a decimal. So you can write that decimal, that's fine. Or you can do math, enter, enter. I'm pretty sure it stays that. X equals 30.375. Or math, enter, enter would take us back to the 243 over 8. If it's a terminating decimal, that's fine. But if it's a one that repeats forever, you might just want to leave it as a fraction. Alright, so this is solving. Again, depending on the form that you have, you do the opposite form to solve for x. So that's what we're going to be doing today. Do I want to show you this yet? We'll do, let's do 7. Let's come down here and do 7. And then I'm going to show you a slightly different way to do it. That might be a little easier for some of you. But others, if you're content with converting, then that's fine. Stay converting. But let's look at number 7 first. Alright, so for this one, we're given the base. We're given an exponential. So we want to isolate the base part. So separate the e from the negative 2. And get this part by itself. So from here, we add or subtract first. So in this case, we're going to add 3 first. So negative 2. Negative 2. I'm going to put times, that way we can separate it. E to the negative 3x minus 8 equals negative 42. And then from here, we divide it by negative 2. And dividing both sides by negative 2. So we divide or multiply next. So divide by negative 2. Divide by negative 2. E to the negative 3x minus 8 equals 21. So once we have the base isolated, this is where we convert exponential to log form. So I know it's exponential because it gives me an exponent. I want to write it as a log. So log e would be my base. 21 becomes the argument. That's what I take the log of. And the exponent is what goes to the other side. So I get negative 3x minus 8. Now we're going to get some pretty ugly decimals here. So I'm just going to type this in the calculator. And then we'll finish everything off there. So this is the part I need to see. Is you getting this far? From here, most of the rest is done in the calculator. So alpha window 5. We're going to put an e here, second divide. And we're going to put a 21 here. Alright, so we get that decimal. So to that decimal, the next thing we solve is what was in the exponent in the grouping symbols. So the grouping symbols was the exponent here. We're going to add 8 to that number first. So we don't add it to the base here. I don't know why I wrote it like that. So add 8 to this number. So I'm just going to add it over here. Add 8. And we get 3x, negative 3x equals this decimal. And then we can divide it by negative 3. So once we get rid of this, then we can divide by negative 3. So take this answer and divide it by negative 3. And then we can round it. Keep those in the calculator. Do not round too early. Because some of these, if you round too early, it'll significantly change your answer. So x is, when we divide it by 3, negative 3.6815. The 5 takes it and rounds it to 2. Okay, so from here, this part you can just do in the calculator. Alright, we'll do one more with converting forms, and then I'll show you the other way, and you can decide which one you like better. Alright, so this one has a base, it's still exponential, has a base of 6, separate the 6 from the 1/3, and the exponent is negative 4. So we want to add or subtract the 1 first, so subtract it from the other side. To get 1/3, I'm going to put the times there to separate them. To the negative 4x equals 5. Now this time, to get rid of 1/3, we don't want to divide by 1/3. We want to multiply by the reciprocal, 3 over 1. So here we multiply by 3. So an important thing I want to note here, these two are not together and you cannot combine them. You cannot say that 1/3 of 6 is 2 and write this as 2 to the negative 4. That you do order of operations. You got to do the exponent first and then multiply. So you just get rid of the 1/3. Don't try to combine your numbers, your a and your base. So you just multiply both sides by 3, and we get negative 4x is 15. 6 to the negative 4x is 15. So again, we're in exponential form, so we need to convert it to a log. So log, the base is 6, the argument's the 15, and it's equal to the exponent, which is negative 4. So again, this one switches to this side, this one goes to this side, and then the 6 comes down. Alright, and then this one is not on our chart. If you look under the 6th row, you're not going to see 15 anywhere in there because it's not a rational number. So we're just going to use our calculator, and I'm going to do it over here to the side. It's in the way. Alpha window 5. And then we put 6 and 12. So we get that it's that number. So if you want to write that number there, you can. But I'm just going to leave it alone. And then we take that and divide it by negative 4. So from here, you just take this answer and divide it by negative 4. Notice I'm not dividing anything inside the log by negative 4. I'm not dividing the 6. I'm not dividing the 15. You divide the entire expression by negative 4, and you get that number in the calculator. So here, this is negative 0.3476, rounds it to 7. So that's what that one stays. Alright, so this is solving, this is all the same case, solving case 2 by converting forms. Now, the part at the top actually has you do a slightly different way. If you like this way better, then by all means use it. Or you can continue to convert forms. So here, let's see if I can get it. So for these two, notice they're still exponentials, but we're going to use the inverse property of logs, which we'll talk about more about properties later, but this is another way to do it. So you can also solve a still case 2, exponential or logarithmic equation by exponentiating or taking the log of both sides. So if it's a log, you exponentiate. If it's an exponential, you take the log. So what that's going to do, that kind of does this property right here. If the base of the log is the same thing as the base of the exponential, they cancel each other out, and you're just left with the exponent here. So here, the base of the log and the base of the exponential are the same, so they cancel each other out, and the answer to this is just 2/3. So that is using the taking the log of both sides property, which is what we're going to use for example 5. This one is exponentiating, which is what we're going to use for example 6. So again, if the base of the exponential and the base of the log are the same, they cancel, and you're left with the argument as your answer. So right here, log, if it's a common log, then the base is 10. So log 10 to the log base 10 of 4. Base 10 and log 10 cancel out. So this answer is just 4. So you're going to see it makes things a little easier, but you have to use these properties right here. The first part is still the same though. You still want to get the exponent by itself. So the base and the exponent need to be isolated. So get these parts by itself. So the first thing we're going to do is add 6 to both sides. So we get 8 to the 3x plus 2 is 11. So then we would multiply if there was an a value, but this one doesn't have an a value. So here, if we were doing the other form, this is where we would convert the exponential form to the log form. If you like doing that, then continue to do that. But because we're given an exponential, we're going to take the log of both sides. So to this one, we take the log with base 8 of this side, and over here, we take the log of base 8 to the 11. So the 11 becomes the argument here. So notice the base of the exponential and the base of the log are the same for this side. So these cancel out. And we're left with 3x plus 2. And then over here, this one doesn't cancel out. So this is the part where we need to use the calculator to get this number. So notice, if you were to convert, you would say, okay, my base is 8, that goes here. My argument is 11, that goes here. And the exponent is 3x plus 2, so that is what it's equal to. It's the exact same thing. I don't care which method you use, as long as you can isolate the x. Okay, so from here, we'd go to the calculator. Calculator. And we would do alpha window 5 to that number. Alpha window 5. And we would put 8 and 11. And we get the decimal 1.15, blah, 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 blah. And then we know to solve for x, we first subtract the 2. So we take that number. We're going to subtract 2 from it. So whatever decimal you get, you subtract 2. And then from there, we get another decimal, and we take it and we divide it by 3. So x is negative 0.2 822. So 822 is just going to stay 82. So again, use this if you want. Ignore it if you want. If you prefer this way, then continue to do this way. So I will leave this one up to you. However you want to solve it. Converting forms is this part. Or taking the log of both sides. You would take the log with base 2. Then go ahead and do that. Because we're practicing taking the logs for these examples, that's what I'm going to do. But if you want to convert forms, then just convert forms on your paper. Alright, so plus 5 plus 5. So we're going to get 2 to the x, because that's the part we're trying to get by itself. 2 to the 0.1x is 12. I'm going to leave a little bit of space for the 12. So there's no a value, so I don't have to multiply or divide. To get rid of the base 2, I log 2 to both sides. So I log base 2 to this side. So this cancels out with this, and I'm left with 0.1x equals log base 2 of 12. Again, really all it does is it makes it switch sides. It keeps the x on the right side instead of switching it to the other side, or the left side, instead of switching it around. Alright, so alpha window 5, 2, alpha window 5, put a 2 there, and a 12 there, and we get 3.58, and we take that, and we divide it by 0.1. So x is, when we divide it by 0.1, we get that x equals 35 point, it's just going to move the decimal back 1, 8496. So 8, this part right here would round to 5. 50. What we get there. Alright, so I really am going to leave it up to you as to which method you prefer. Do you prefer converting or do you prefer taking the logs? Either way, just make sure you can get to the other form. Alright, and then example 6 is using this one. So the last one, I think here, is going to be using the exponentiating both sides. So if you look at example 6, we're still trying to isolate the log part. So here the log is basically everything because it's what's in the argument and then the log itself. So that's everything over here. Over here we're isolating the log and the argument ends at the 7. So for this one we actually don't need to do anything. We can go straight to converting. Over here, let's go ahead and add and subtract all the other stuff. So we're going to subtract or add first. So we'll subtract the 8 from the 10. Oh, it's already going to be a decimal. 3 log base 8 of 2x plus 7 equals 2. And it's still not completely isolated, so we need to divide it by 3 first before we can exponentiate. So log base 8 of 2 to the x plus 7 equals 2/3. Alright, so here's how exponentiating works. So right now it's a log, so I want to make these exponents that have the same base as the logarithm. So what I do is I take all of this and I raise it to the exponent. So the base I want to be 4, all of this stuff becomes an exponent. And really, eventually I'm not going to write all of this out again, but I want you to see what's happening here. So I'm taking everything and I'm exponentiating this side. Whatever I do to one side, I have to do to the other. So to the 5, I make the 5 an exponent to the same base. So here, the base of the exponential and the base of the log are the same. So these are going to cancel out. And I'm going to be left with just the argument. 10x plus 624 equals, this is just a number, so I'm going to leave that as is right now, 4 to the 5th. But that's what exponentiating means. Exponentiating means to make an exponent. So you take the stuff that's there and you make it an exponent. Eventually I cheat and I just put a big 4 in front and a big 4 in front. But this one I wanted you to see what's actually happening. Alright, so if we use our little poster, 10x plus 624 is 4 to the 5th. 4 to the 5th is 1024. And then we can just solve the rest in the calculator. So from here, I mean this one is actually not a bad one to do just by hand, but so here's 1024 and then we subtract the 624 and we get 400. So subtract 624. So we can show the steps for this one because they're not decimals. Equals 400. And then divide it by 10. X is just 40. So divide it by 10. Oops, 400. X is, come on, just the 40. So, nope, don't want to do that. So right here, X equals 40. Now, something I haven't been doing really is checking. But with logarithms, the only time you have to check is when there's double logs. Because double logs, when they cancel each other out, that's when other stuff happens. Here, if it's a negative number, you would run into problems up here. Because you would get negative as the exponent, and you can't have that. So you would run into a problem earlier than the very end. It's when you have the double logs that you run into the extraneous solutions. So the last one here, I'm going to kind of cheat. So I'm going to exponentiate both sides with the base of 8. So all that means is I write a base of 8 here. So now that's the base. This is the exponent. The base of 8 here. That's the base. That's the exponent. So the base and the base cancel out. And we have 2x plus 7 equals, here, once again, we run into rational exponents. So we're going to need to do the cube root of 8 squared. So the cube root of 8 is 2. 2 squared is 4. So this one I can just set equal to 4. And then just finish solving for x. So I'm going to run out of room here, so I'm just going to do it by hand. Subtract the 7 to get -3, and then divide it by 2 to get